Today I want to discuss what is the solar module, what is the solar panel and the array, and the specifications of the solar module, panel and array. So what is the solar module? The solar module is an assembly of solar cells mounted in a framework for installation, that is the solar module, and then a collection of solar modules is called a solar panel, and the solar array is a collection of multiple solar panels that generate the electricity as a system. So now sunlight hits the panels in an array and produces the direct current, that is DC current, electricity. The array is connected to an inverter system and the inverter converts the DC electricity to usable alternating current, that is AC electricity. Now a single solar cell has very limited output capacity, such that a single crystal silicon cell output is about 0.5 volt. So the cells are joined in series and parallel to increase their output capacity. Just like 36 SC silicon cells are connected to produce a 24 volt module. Further increase if required in the output capacity, then the panels are joined together into the solar arrays. Photovoltaic modules use the light energy of photons from the sun to generate the electricity through the photovoltaic effect. Most modules use the wafer-based crystalline silicon cells or the thin film cells. The structural, that is load-carrying members of a module can be either the top layer or the back layer. Cells must be protected from the mechanical damage and moisture. Most modules are rigid, but semi-flexible ones based on the thin film cells are also available. The cells are connected electrically in series one to the another to the desired voltage and then in parallel to increase the amperage. The wattage of the module is the mathematical product of the voltage and the ampere of the module. The manufacturer specifications on solar panels are obtained under the standard condition, which is not the real operating condition. The solar panels are exposed to on the installation site. A PV junction box is attached to the back side of the solar panel and functions as its output interface. External connections for most of the photovoltaic modules use the MC4 connectors to facilitate easy weatherproof connections to the rest of the system. An USB power interface can also be used. Module electrical connections are made in series to achieve a desired output voltage or in parallel to provide a desired current capability of the solar panel or the photovoltaic systems. The conducting wires that take the current of the modules are sized according to the ampacity and the may contain the silver, copper or other non-magnetic conductive transition metals. When the sun shines, as long as the voltage produced by the panel is greater than that of the battery, charging will take place. However, in the dark, when no voltage is being produced by the panel, the voltage of the battery would cause a current to flow in the opposite direction through the panels, which can lead to the discharging of the battery. Hence, a blocking diode is used in series with the panel and the battery in reverse biasing. This is the blocking diode attached in the series to the panel. Normal PN junction diodes can be used as the blocking diodes. To select the blocking diode, the following parameters should be kept in mind: the maximum current provided by the panel, voltage rating of the diode, and the reverse breakdown voltage of the diode. When one or more cells of the panel is shaded while the others are illuminated, then the hotspot phenomenon is occur. The shaded cells or the panel starts behaving as a diode polarized in reverse direction and generates the reverse power. This is the hotspot region and this is the hotspot characteristics when the cells are in shadow, and this is the normal illuminated cell characteristics. So the other cells generate a current that flows through the shaded cell and the load. Any solar cell has its own critical power dissipation, that is PC, that must not be exceeded and depends on its cooling and material structures, its area, its maximum operating temperature and the ambient temperature also. So a shaded cell may be destroyed when its reverse dissipation exceeds the critical power PC. This is the hotspot. To eliminate the hotspot phenomenon, a bypass diode is parallelly connected to the module or group of the cell in the reverse polarity, which provides another path to the extra current. So this is the blocking diode connected to the series of to the cell, and this is the bypass diode connected parallel of the panel. So the bypass diodes may be incorporated or used externally in case of partial module shading to maximize the output of the module section still illuminated. When if the part of a PV module is shaded, the shaded cells will not be able to produce as much current as the unshaded cells. Since all cells are connected in series, the same amount of current must flow through the every cell. The unshaded cells will force the shaded cells to pass more current through it. These are the cells connected in series, and if the cell voltage is Vs and there is a n number of cells are connected in series, then the forward voltage Vf, that is the bypass voltage, is equal to the cell voltage minus n minus 1 into the V cell. The only way the shaded cells can operate to a current higher than their short circuit current is to operate in a region of the negative voltage such that to cause a net voltage loss to the system. The voltage across the shaded or the low current solar cell becomes greater than the forward bias voltage of the other series cells which share the same bypass diode, thus making the diode to work in forward bias and hence the allowing extra current to pass through it, preventing the hotspot. For an efficient operation, there are two conditions to fulfill. One is the bypass diode has to conduct when one cell is shadowed. The shadowed cell voltage Vs must stay under its breakdown voltage Vc. Ideally, a bypass diode should have the forward voltage Vf and a leakage current IR as low as possible. Two types of diodes are available as the bypass diode in solar panels and arrays. That is one PN junction diode and another is the Schottky barrier diode. This is the PN junction diode and this is the Schottky barrier diode. To select a bypass diode, the following parameters should be considered, that is the forward voltage and the current rating and the reverse leakage current of the diode, reverse breakdown voltage of the diode and the junction temperature range. Some special solar photovoltaic modules include the concentrators in which light is focused by lenses or mirrors onto the smaller cell. This enables the use of cells with a high cost per unit area, such as the gallium arsenide, in a cost-effective way. Solar panels also use the metal frames consisting of racking components, brackets, reflector shapes, and through to the better support the panel. Open circuit voltage defines the output voltage when no load is connected under STC. Example, the VOC 45.4 voltage determines the maximum possible voltage and the maximum number of modules in series. Short circuit current defines the protection level of the electrical casing at the back of the panel, also includes the number of bypass diodes if it is used. The ISC, for example, is 5.69 ampere. It determines the current rating of fuse which is to be used for the protection, and the conductor size also. Now the IV characteristics defines the current and voltage variation for the panel, also shows the IV characteristics for different irradiance. For the different irradiance, the module current should be the different. This parameter determines the module current and the module voltage for a particular value of irradiance. This can be used to obtain the output voltage at the lowest irradiance for a region. Different irradiance, in different irradiance, the different module voltage and the module current should be different, and the maximum power point also should be different. So it should be considered. Now the module efficiency. This parameter helps in solving the problem of the choosing a module. The 15.3% efficiency for the thin film, that is 12% efficiency. So the efficiency, module efficiency, can define the conversion efficiency given by the given module, which is generally lesser than the single solar cell used in the module. Operating temperature defines the range of temperature for which the module can function, that is 85 degrees centigrade, 40 degrees centigrade to 85 degrees centigrade. Determines the temperature range for the environment in which the panel can be kept. Maximum series fuse rating defines the maximum current which can be handled by the module without damage, 15 ampere. For an example, this defines the rating of fuse to be used in the module. Power tolerance defines the range of power deviation from its stated power rating due to the change in its operating condition. It is defined in percentage, that is 0 to 5%. This parameter determines the upper limit of the power of a module. Now the parameters defined under NOCT, these parameters are same as defined under the STC conditions with the different values. Difference between STC and NOCT means the STC means the standard state test conditions when the irradiance is 1000 Weber per meter square, watt per meter square, and the module temperature is 25 degrees centigrade, air mass is 1.5. But NOCT is the nominal operating cell temperature when the irradiance is 800 watt per meter square, ambient temperature is 20 degrees centigrade, wind speed is 1 meter per second. Now the temperature coefficient. The normal nominal operating cell temperature NOCT is 45 plus minus 2 degrees centigrade. Temperature coefficient when the power is maximum, that is minus 0.45 degrees centigrade, 45% per degree centigrade. Temperature coefficient of the open circuit voltage, that is 0.34% per degree centigrade. Temperature coefficient of the short circuit current when 0.050% per degree centigrade. These parameters can be used to calculate the power, current, and the voltage of the module. The temperature coefficient of VOC can also be used to determine the maximum panel voltage. at the lowest expected temperature. Now the packing configuration, the piece per pallet, that is number of modules per box, pallet per container, number of boxes per container, and the pieces per container, that is number of modules per container. So pieces per pallet is 26, cross pallet per container is 12, then the pieces per container is 312. Now the selecting the right technology, how to choose a suitable solar panel. This is the first, select the right technology. The selection of solar panel technology generally depends on space available for installation and overall cost of the system. Determine the solar panel efficiency under different conditions and over time and compared to industry average of 16 to 18%. Check the solar panel manufacturer warranties against the industry average of 10 to 25 years. Check the operating specifications beyond the STC rating. Negative tolerance can lead to a lower system performance and reduce the capacity. So by these 5 parameters you can choose the suitable solar. Now if you go through the references, then you will get the details about it. Thank you.